In this screencast, we're going to learn how to take a SOLIDWORKS model of the motor in your 101 kit and assemble it into a chassis and then attach a wheel. So first, go to tinyurl.com/101parts with a capital P, and that will lead to a zip file which you'll download. So download that to your desktop. And here's that 101 parts folder unzipped. The parts in it are first the servo, the RC servo, and that consists of two parts in assembly. First there's the servo body, and then there's the arm, and finally the servo itself. You notice I put these little red pins in. Any part that you see like this that's red is not actually a part of the component, but it is a placeholder so that when the component is assembled next to a wood part, this will laser cut. If you keep this part in and it has the circle, that will laser cut an appropriate hole to match up with this part. So the servo has those. The ball caster, that's in your kit. That's to stabilize the robot if you have a two-wheel drive robot. And you can see there's little red dots there to cut out holes for the screws. This is the barrel that's 1 inch diameter, 4 inches long. This is the most complex and important part, the gear motor, of course. And we'll be working with that in this video. Finally, there's two 1/8 inch pins. They're 1/8 inch diameter. This one is a 1/2 inch long, and this one, although the picture is the same, is 1 inch long. And finally, there's a terminal block that you'll use to transfer wires, and you don't need that part until the very end. And here's the GM2 gear motor that I've opened in SOLIDWORKS. You can see it has the good model of the motor, and I've added these red parts so that we have cutouts where we need them. This is just a locating boss, that part right there. It's just a plastic piece, but it helps locate the motor into the plywood so that it doesn't rotate. These two bosses, that one and that one, those are for the main mounting screws. This extension is so that we have this shape cut out into the wheel, as we'll see later, and this boss is to make a cutout in the plywood so that the hub can fit all the way down into the motor. And one note on the sizing of this shaft for the axle. I've actually gone into the existing SOLIDWORKS file for this motor, and I've adjusted the size of this shaft in the boss extrude. I've done that. I've chosen these dimensions so that when the mold cavity command is used and the hole is made in the matching wheel, that resulting hole will be a snug fit onto an actual plastic motor. So in other words, I've accounted for the laser cut width, which is called kerf, K-E-R-F. I've accounted for that in sizing these already, and that's true for a lot of the parts. It's also true for these pins, these 1/8 inch pins. They're actually 0.125 inch diameter, but when you look at the pin size, I've designed them to be 0.120 diameter. And again, that's so that when you use mold cavity and it cuts a hole, the laser will cut it at 0.120, but the actual hole that results will be about 0.125. And so you get a nice snug fit or a slip fit, but you don't get any slop. And let's start by making a mock chassis for this part. My chassis is not going to be nearly as big as yours would need to be. It's just a demonstration. So we make a new part, check our units, make sure we're in the inch system, and let's do an extrusion. And I'll do something I'll make the right side. You can either use a corner-to-corner rectangle or a regular one. This one doesn't really matter. So I'll make a side like this. So I've dimensioned it, and I'm completing the extrusion, and this will be made of the same plywood, so we want to extrude it to a thickness of 0.11 inches. And probably the most important part of working with this part is to save it in the right place. So when I click on Save, make sure that this part the side in this case, goes to the same folder as the other 101 parts. If it goes to a different folder, then you can have the some parts in mixed folders, and then when you try to move these files to another computer, it will not be able to find them. So just make sure it's going to the same place and save that. And now I'm going to make an assembly. So I go New, Assembly, OK. I'm going to put in a part I've already made. This is a bottom. That's a mock bottom with fingers already. And I'm also going to insert a side. And remember to check your units. This assembly started out within the millimeter system, so I'm going to switch to inch. And now we're going to mate these together. And you probably remember how this works. We click on a surface that we want to mate to another surface. And that is not the kind of alignment I wanted, so I'm going to hit the mate alignment like that to get the fingers to penetrate into that surface. Then I can align the backs. Oop, I forgot the green check. I'm going to hit the back surface to the back, green check, and then the bottom to the bottom. Now this one I'm not going to hit the green check just yet. I want to show you another possibility. Certainly this finger joint would work. That's just like we did our boxes. If you want a little bit stronger joint, it would be nice to have the bottom higher up so that those fingers are captured from both top and bottom. And that's easy to do with this little button right here, the distance alignment. So I click that, and now let me flip the dimension so it moves it up. And then I can type in, I'm just going to guess here, 0.6 to put it somewhere in the middle. Don't copy what I'm doing here for dimensions, but just introducing this as a possibility for how you can do your parts. And let's remember to save this one also in the same folder as our other parts were. It says they're not going to show up because it's looking for assembly files. So I'll call this robot assembly. And the next step would be to make the cutouts. So you probably remember how this works. We are wanting to make cutouts in the side, and so we go right click on side, edit part, and then we go insert, mold, cavity. And then we click on the part that we want to do the cutting out operation, which is that one. Hit the green check and get out of edit component. And now we have those cutouts, and we can inspect that by opening the side part, and sure enough, there they are. And so let's go back to the assembly. And now we're ready to put our motor in. So I'm going to insert a gear motor, and we want to mate this. So first mating operation I would suggest is the face there of the motor to the inside face of the side, like that. And I want to rotate that motor around, green check. So I'm going to make that surface parallel to that surface. Although I wanted to flip that, so I'm going to do mate alignment that way. And I don't want it right on the edge. I'm probably going to want to put it inboard a little bit. I'm going to, let's see, go in by a 1/2 inch. And we'll flip that dimension. Nope, we'll do another flip of the mate alignment. And now we'll flip the dimension. Okay, so that puts it in the proper fore-aft position. So you can see playing with flip dimension and mate alignment is how you adjust things. And finally, I want to mate it up and down. And I think you'll get a little more stability out of the motor if you mate that surface to the floor in some way. The motor is held on primarily by 2 screws, one there and one there. But 2 screws might not be enough to fully make it rigid, and so the floor will provide some added stability. Okay, and then we'll finish the mate operation. Now, I just put this motor in relatively arbitrarily fore and aft and for orientation. For your robot, you want to think about some issues. For example, if this is the back of the robot, then you'd probably want to move this motor closer to the back. If this is the front of the robot, then this orientation would not be very strategic because we're having the robot motor stick out into the middle of the section. Probably you would want the motor towards the backside to give yourself a little more room. However, I don't want you to assume that we're looking at the motor in the orientation it has to be, right? Nothing that says we couldn't have it oriented like this, and the bars would be on above the plane and the motor below. So definitely explore those options and many others. Just make sure that you've thought about your design and optimize the placements to achieve the kind of goals you want. And next we'll do our mold cavities command like we have done so many times. So now we're doing a cutout in the side. So I'm going to right click, edit part, insert, mold, cavity, and then you can click any part of the motor. It will recognize that as the motor. Complete the cavity. Now this is a good dialog box to pay attention to. It says bodies to keep, all or selected. And the reason it's telling us this is that right in this region here there is a free body, something that's not attached to anything else. And in fact we don't want to keep it. So say selected, and let's just try them. Body 1 you can see is the main part of the side. Body 2 is just that little piece that we do want to get rid of. So let's not do body 2, just do body 1. Click OK, and let's get out of Edit Component. And now you can see why I have this red circle to do the cutout. It will eliminate the wood where we need it to be gone and make room for a hub that's going to be installed there. And now we're ready to make our wheel. The wheel's going to sit inside this space, and this diameter right here, that's the cutout, that will be the laser cutout in the plywood, and that has a dimension of, we can see 0.7 inches. So our hub should be probably 50 thousandths or a little more or smaller than that, so that we don't rub on the side. But it is helpful to make the hub reasonably big so that the rest of the wheel is well supported on the axle. You can see the axle itself, that portion is not very long. And so the hub is going to bottom out on this surface. The hub will be placed down to that surface, and the hub will move us out along this shaft and grab the shaft. And then when we have sufficient clearance from the side of the side, then the rest of the wheel can start. The whole thing will be held on with a screw, which you can't see, but there's a hole, if you might remember, running down the length of this axle to clamp it to the axle. So now I make a new part, and this one is going to start with a hub. I'll put it arbitrarily on the right plane. Use the circle, start at the origin, and the first dimension is just the hub, so this is small. I'll make mine 0.6 inch diameter, so that'll give a generous clearance to the rest, but still get very good support for transitioning from that small axle to the big wheel. And when I exit this sketch, it's going to ask me for a thickness. And your two choices are one thickness, 0.11, or two thicknesses of it. I'm going to do two thicknesses just because that's a little more conservative. It'll give us a little more space. But you might only need one, depending on how things bolt together. Now, implicit in this decision that I just made is that I'm going to, for this video, I'm going to show the wheel built up out of multiple layers of wood. And there's going to be, in my wheel, there's going to be a total of 5 layers of wood, but they're all going to be in one part. Certainly that's not the only way that you could do this. You could have 5 individual parts. I find the fewer parts I have to deal with, the better, just in terms of the way my mind works. However, it does require a little more work later on, because then you have to sort out this single part into its individual 5 layers. So that step would happen on the DWG file exportation. So you can work either way, but I just want to clarify how I'm working. Okay, so we have the hub built, and now let's build the rest of this wheel. The wheel is going to consist of 3 parts. there's going to be an inside part. This is next to the hub. Okay, and I'll make this of a substantial diameter. Let's say it's 2.5 inches. That's a fairly big, maybe typical wheel. And we're going to extrude this one. This will just be extruded by 1 thickness, so 0.11. Okay, we'll finish that thickness. The next piece of wood we're going to play in here is going to have a little underset. It's going to form a groove so that an O-ring can be tensioned around it, a square profile O-ring. So I'm going to make another extrusion on this face, but I suggest that you don't use the circle command for this one. So you remember that our wheel size is a very important variable for optimizing the performance, and it's very likely we're going to want to adjust our wheel size as we go forward. So here's a technique to do that. Instead of creating an independent circle, let's use the Offset Entities button to make a circle that is always some distance smaller than the first circle we made. And so you can see the yellow line is what it's trying to make. We want one that goes to the inside, so we click the reverse button. And for the O-rings we're using, I would suggest you use 50 thousandths, 0.050 inches smaller on the radius than that inside edge. So this is a number that you can indeed copy from what the video I'm doing right here. It doesn't have to be exactly 0.05, but that has worked well in the past. Okay, so we're going to exit that sketch. It's the same 0.11 thickness. You can see we're building up our groove. And now we'll do one more disc to capture the O-ring. So one more extrusion on that face. And in this case, I want it to be the exact same size as the first one. So the simplest way to do that is the Convert Entities button. This button will take entities that are not on the plane we're sketching on this plane. It'll take entities from a different plane and move them. See that it grabbed the edge. I click the green check, and now you're going to see a black line appear on the plane we're working. Okay, so that's the circle that will always be the same size as the first circle. Okay, exit this sketch, same 0.11, and now we have our wheel. And the beauty of this way of designing, this parametric design, is that we only have to change one dimension, the dimension of this first circle, and the wheel will automatically adjust to everything else. So let's see if that works. If I go back to sketch 2, edit sketch, if I change that 2.5 to 1.5, and I hit check, and I exit the sketch, it rebuilt the wheel with that groove still 50 thousandths smaller. Okay, so I'm going to hit Control Z to bring it back up to the 2.5, and there's our wheel. And let me save this wheel, and again I want to make sure it's going to the same folder. So I'm going to call this wheel. And now we're going to assemble that wheel to our assembly that we started. Okay, and we're going to put it on the axle. So go to Insert Components, Wheel, and it's coming in not the orientation I was hoping, but that's no problem. We're going to mate this surface to that surface right there or right there. Those are the surfaces that the wheel will bottom out upon. And in this case, it did line it up correctly, but you might need to use mate alignment or flip direction. Well, actually just mate alignment in this case. Okay. Now the next, for a wheel, the next alignment you do, you have a couple choices. You could do concentric circles. That's a very simple and effective way to align a round object to another round object. So for example, if I click that round and any other round that's concentric, say I grab that one, that will put them in that orientation, and it gives you a convenient button here, Lock Rotation. There are ways to orient it axially or rotationally, but they take a few steps. The easiest way is just click that. Okay, and now we have the wheel mated onto the motor shaft. Okay, next thing is to do the cutouts. So we know that we want to make this axle cutout in the wheel, so we know how to do this. Right click on wheel, edit part, insert mold cavity, and click on the motor, any part on the motor. It'll recognize that that is what it needs to do. It'll recognize the whole thing. Click the green check, get out of edit component, and now when we go into our wheel part, we should have that nice cutout all the way through. Now you might be wondering, why am I making the cutout all the way through when we know that the axle is probably only going to make it to about there or there, somewhere in there. And the reason is that we want this wheel to be assembled with all the pieces very concentric. And the best way I know how to do that is to use the axle shaft itself to align those inner surfaces. So I actually don't assemble this wheel starting with a hub. I assemble it starting with this outside, then I slide on the middle piece, then I slide on that piece. And actually I think by that point you've already exhausted the length of the hub. I glue those together, then I glue these two together, and then I glue them to each other, or actually you don't even have to. You can leave a space between them and the screw will probably hold it all together. The gluing and alignment technique is important because if these three wheels are not glued together concentrically, then imagine what will happen as it rolls. If that wheel is taller than the rest, that means the axle does not go straight through perpendicular to the assembly. The axle will go through at some angle. And if the axle goes through at an angle to the wheel assembly, then the wheel is going to wobble like crazy when you try to drive it. So this is what you might be called design for manufacture, is that I'm thinking about how it's going to be made and I'm designing the parts so that it will come out with high quality. Let's go back to our assembly, see how this is looking. You can see that this assembly would work very well if the robot is oriented like this and the bars are on top, because I have plenty of clearance down here. It would be a little awkward if this was oriented like this, because the siding is only a little bit above the contact point of the wheel. So if I were orienting like this, I would move the side up relative to the other surfaces so that I have more ground clearance. Okay, the next step is I want to show you a nice way to do the left side. Very simple. We're using the mirror command. So rather than manually reinsert and mate these components to the side, instead we use, under linear component, mirror components. So it's asking us for a mirror plane and components to mirror. So the mirror plane is most easily found, depending on how you design your bottom part, with a plane in that part. So if I open up the bottom there, when I made this part, I used the center rectangle like we usually did in the box, and I'm looking for the plane that would be a mirror plane, and it's that one. So I click that, and that populates there. And now components to mirror. I just click on the components. I don't need to hold control because it's expecting a list here. And those three parts are now going to be put onto the left side. So I hit check, and sure enough, there they are. So that saved a lot of work. Except, as you see, this hole is not in the right place. That probably is traceable to some of the assembly reorientations I did, like the flips and such. And so we're going to have to give it a little bit of help to get this where it needs to go. Scroll down till you see that latest mirror component. Hit the plus, okay, and those are the three components mirrored. And actually right-click, we didn't need to hit the plus, right-click on mirror component, and let's edit this feature, which is right there. And we want to click on this little blue arrow right here. That will give us access to more control on this mirroring. And you can see here's the three pieces, and it has some reorientations that are possible. So the wheel is fine. the motor is fine. It's the side we want to reorient. So let's just try these one at a time. We can see the hole is there on the side now. Click once, and let's see if it puts the hole. I believe that's the one we want, because the hole is where it needs to go and the finger holes are where they need to go. You can try the others. That's not right, and that one's not right. So it's the second orientation. So we're happy with that. Hit the green check, and now it's got the parts oriented as they should be. One last tip, in case you didn't have a mirror plane, if this part was not done with the center rectangle, then it wouldn't have a convenient mirror plane, but we can put one in. So this is done in reference geometry, and go to plane, and now it's looking for some references to place this plane. So the first reference is the plane itself. So let me click a plane that's parallel to, I should say the first reference is a plane that is parallel to the plane we're interested in. And now I also want to set some other references. I want to set it to that midpoint, and you have to click one more midpoint for it to really know where that plane goes. And one more time, there we got it. So that plane is fully defined. You need to get the green. So keep hitting midpoints till it says it's green. Hit the green check, and now you have a plane that you can select as a mirror plane. It would show up in this tree.